Hello everyone, welcome to the Purnima University. Myself, Mr. Ankit Khandelwal, Assistant Professor from the Department of Faculty of Computer Engineering. We are having a discussion on the course Computer Organization and Architecture, and the topic of discussion is Boost algorithm for the division. Today we are going to have a discussion on the method that is called restoring division method through the Boost algorithm. The content of the lecture are as follows. First of all, we will see the introduction about the Boost division algorithm. Then we will see some points to remember regarding the algorithm. Then there are some steps for restoring division process. We will see all those steps, how to do the division method or how the division process take place inside the computer system there. We will take an example and we will understand this Boost algorithm restoring method with the help of an example there. So after completing this lecture, the student will be able to understand Boost algorithm. That is, they will explain the concept, significance, and advantage of Boost division algorithm in handling signed binary numbers there. They can perform division. That means they can apply Boost algorithm to divide two binary numbers effectively. Two types of division algorithm are there. In this lecture, we are going to have a discussion on the restoring division method there. Boost division algorithm is an efficient method for signed binary numbers similar to Boost multiplication algorithm there. However, division is more complex due to handling both positive and negative numbers in two's complement representation. There are two methods. One is restoring algorithm and another one is the non-restoring algorithm there. So the points to remember are these. First of all, we have to decide which operand will be the divisor and which will be the dividend. Then convert both the operands, that is the divisor and the dividend, to two's complement representation using x number of bits there. And x must be at least one bit more bit than is required for the representation of numerically large operand. As we know that whatever decimal number you are taking, when you are converting that into a binary format, you have to apply a sign bit, that is one extra bit to that. If it is positive, we are going to implement a 0, and if it is negative, we are going to have a 1 on the magnitude side there. So steps for restoring division method. The step one is, first of all, we have to initialize the registers. There is a register Q which is going to hold the dividend. There is a register M which is going to hold the value of divisor. A register which is equal, and N is the number of bits that are in the dividend there. Then step two will be like this. The content of we will subtract the content of accumulator and Q. First of all, they will be shifted as by considering them as a single unit AQ. So first of all, we will shift A and Q towards the left hand side, considering them as an AQ register. Then step three will be the content of register M is subtracted from A and result is stored in A there. This is the step three. Then step four, the MSB of the A is checked after the subtraction. If it is 0, that is the least significant bit of Q is set to 1. Okay. Otherwise, if it is 1, that means if the MSB of the A after subtraction is 1, then least significant bit of Q is set to 0 and value of register A is restored. This is the step number 4, which is very crucial. Okay, so what we have to do? We have to do step 2, that is we have to shift left the register A and Q, considering them as a single register. Then step 3 will be we are going to subtract M from the accumulator, and result is stored in accumulator itself. Then what we will there? We will check the value of accumulator, that is the MSB, most significant bit of the A. If it is 0, that means the result is positive, then the least significant bit of the Q will be 1. If the result is negative, that is after subtraction, we got a negative value, that is most significant bit of the accumulator is 1, then LSB of Q will be set to 0. Okay, and the value of register A will be restored there. Step number 5, we will decrease the value of counter N by 1, and if the value of N becomes 0, then go to the next step, otherwise repeat from step 2 there. Okay, and step 7, we'll got two things there, that is quotient and the remainder. The quotient will be available with the Q register and the remainder will be available with the A register there. Okay, so this is the final steps. You are going to have a quotient in Q register, okay, in Q register, and remainder in the A register there, right? Now let us take an example. So find, that is, we are going to divide 11 by 3 by using the restoring division algorithm method there. So step number 1 is that we have to store the initial values of the register. So we are taking a Q register which is going to hold the value of dividend. Okay, we are going to hold the value of dividend. M is going to hold the value of divisor. The initial value of accumulator register will be 0, and N is the number of bits in the dividend there. So let us take first of all, Q is going to hold the value of 11 there. Okay, so 11 is 1011. Okay, and we are going to have an extra bit over there which is going to represent the magnitude of the 11, so we are taking that as a 0. Fine, we are taking that as a 0. So this is the value of Q, which is equals to, which is representing a dividend, right? Then we have AM register. We are going to have a AM register. AM is going to hold the value of 3 is 1 1. Okay, and now we are going to implement, as the minimum number of bits to represent 3 is 1 1, and the dividend is having number of bits 1 2 3 4 and 5, total 5 bits, total 5 bits. So we are going to take the divisor also of 5 bits. So we are making the same length. Okay, so we are going to have a 3 bits in front of 1 1 to make a divisor there. So this is divisor. This is divisor of 5 bits. The initial value of accumulator will be 0. So that is 5, 1, 2, 3, 4, and 5. So this is accumulator. This is accumulator. And value of n will be equals to 5. Okay. So in and all, when we are going to start this algorithm, total steps will be 5. Okay, so total steps are going to be 5 there. So all these are the initial values. This is the step number 1. Now we are going to make a table, and in that table what we are going to have, we are going to have an accumulator. Okay, we are going to have a value of dividend, that is Q, and we are going to have a value of N there, right? N. So the initial value of accumulator is 0 0 0, 5 times 0, and the value of Q is 11, because this is dividend, so we are going to hold a value 0 1 0 1 1 there. Okay, and initial value of N is 5. Okay, so we are going to have this thing. So these all are the initial values. Now the thing is that uh, we have a one step in which we are going to do a subtraction. That is, we have seen over here in the step number 3, we are going to have a subtraction. So a equals to a minus m there. Okay. So the m is holding the value of 3. So actually, when you will perform a equals to a minus m, okay, which is equivalent to a plus minus m. So we are going to have a negative value of the divisor there. So for that, what we will do, we will take the 2's complement of the 3 there, and we will add it to the accumulator when we are doing the subtraction, because we know that the subtraction is performed with the help of the 2's complement method there. So this is the thing there. So the two, step 2 step 2 says that we have to shift left the contents of A and Q considering both AQ as single register. Okay, so we will shift that. Okay, so we are having the shifting operation. So shift left operation we are going to implement. So we are going to shift the values. So 0 will go out of the register there. So we are going to have 0, 0, 0, and this 0 will be shifted to the accumulator 0. Then we have 1, 1 is shifted over here, 1, 0, 1, 1. Okay, and this least significant bit will left vacant. Okay, we will fill it after doing the step number 3, which is the subtraction. That is, the value of m will be subtracted from the accumulator. On the basis of the MSB, we are going to define the value of this qn bit there. Okay, now step number 3 is what? Step number 3 is step 3. Step 3 is subtract m from accumulator. That is a equals to a minus m, or a plus minus m there. So what is the value of m? M is equals to 3. So minus m will now become this is the binary value of m. So minus m will become minus 3, which is equivalent to 1, 0, 1, 1, 1 there. We are taking the 2's complement. Okay. Now step number 3 is we have to subtract. So we are performing a equals to a minus m. Okay. Or you can say that a equals to a plus minus m there. So I am going to add the value of accumulator and this. So the value of accumulator is 0. Okay, is 0, which is in the step number 2 after the shifting operation. This is the value of accumulator. Okay, accumulator value is 0. So 0, 0, 0, and to this we are going to add the value of minus m there. So minus m is 1, 1, 1, 0, 1 there. Okay, so we are going to have 1, 0, 1, 1, 1. Okay, this is the value of accumulator after the subtraction, after the subtraction layer. So till now what we have done, we have initialized the values of accumulator, the Q and the N. Now we have started with the step number 2. Step number 2 is what? We have to shift left the contents of A and Q, considering both them as a single register. So if we shifted left both the values, and during this operation, the last bit of the Q will remain vacant. Okay, this value will be depending on the step number 3. What is step number 3? In step number 3, we are going to subtract M from the accumulator, that is A equals to A minus M we are performing, or you can say that we are adding to the A the 2's complement of the M value there. So we have added these two values, and now see what we got in the accumulator. In the accumulator, we got the value equals to MSB equals to 1 there. So that means we are getting the value of as a negative, because what we are doing, we are subtracting 2 minus 3, which is obviously going to give a negative answer. So what was the algorithm saying? Algorithm was saying that if the MSB of the A, we have to check it. If MSB is going to be 1, then LSB of Q is set to 0. We will set it to 0, and the value of register A is restored. We have to again restore the value of A there. So step number 3, we check the value of MSB. This is the value of MSB, which is equals to 1 there. Now what we are going to do, we are going to restore back the value of A. Okay, the value of A at this step is 11101. Now we are going to again restore it to back. Okay, so how we will do that? Now first of all, the MSB is 1. That's why the value of Q naught, this value will become 0 there. Okay, so we have this thing there. Step number 4. Step number 4 is step 4. Check the most significant bit of the accumulator. We found it to be 1. So the LSB of the Q register will be set to 0. Okay, so we are going to have this thing, accumulator Q and N. Okay, so accumulator value is, after doing the subtraction, 11101, and the value of Q register is 101011, and now we are going to introduce 0 to the LSB of the Q there. Okay, this is number 3, whole step number 3 there. Now step number 4, we have done this. Now step number 5 is what? Step number 5 is we have to restore back the value of A register there. So how we are going to restore? The restore method is the value of A is 11101. To this we are going to add value of M 0011. So basically, how you are restoring? You are doing A equals to A plus M there. Okay, so we are going to restore back. So 1 and 1 0, 1 carry, 1 and 1 0, 1 and carry, 1 and 1 0, 1 carry, 1 and 1 0, 1 is carry, 1 and 1 0, and 1, the carry will be discarded. Okay, this carry will be discarded. Okay, so this is step number 5 there. Okay, right? So this is the whole steps which we have followed. So in the step number one, we have initialized the value of the all the registers. Then step number two, we have shift left the contents of A and Q, considering both A and Q as a single register. So after doing the shift left operation, what we have done, we have subtract the value of M from A. Okay, and after doing the subtraction, we have checked the value of accumulator register. We found it to be negative. That is, the MSB of accumulator is 1. That's why the Q not value, that is the LSB of the Q, is set to 0 there, because it was 1. The MSB of accumulator was 1, that's why it is set to 0 there. Then if the result of accumulator is negative, we have to restore back the value of A by adding M to the content of the accumulator. So we restore it back, and in the final step, what we are having? We are having in step number 6, the values are 0, 0, 0, 0, 0. These are the contents of the accumulator. Q register is holding 1, 0, 1, 1, 0. Okay, this. So all the steps are now finished over here. This you can say that this is the pass one of the move on to the, we will check the value of n be decremented by 1. So the value of n is 5. Now it is going to be 4. It is going to be 4. The value of n is 4. For the next step, the value of q is 1, 0, 1, 1, 0, and the value of accumulator is 0, 0, 0, 0, 0. This is the for the next step of the algorithm. How many steps we have to do? We have to do the 5 steps. We have done 1 step. Now remaining is 4 steps there. Okay. So now again all the steps will be repeated there. So if we are going to repeat all these values, let us see the step number, this thing. So the values are accumulator, Q, and N. N is 4. Q, the value of Q is 1, 0, 1, 1, 0, 1, 0, 1, 1, and accumulator is 1, 0. Okay. So step one is what in the next pass? This is pass number 2 of algorithm. Okay. So first step is shift left operation. So we are going to shift left 0, 0, 0, 0. This 0 has been shifted here. This 0 is shifted here. This 0 is shifted here. This one will come over here. And Q will be Q1, 1, 0, and we will left this blank. Okay. The value of this LSB of the Q will depend upon the operation that is we are going to perform in the next. In the next step, what we do? In the next step, we do the subtraction. Okay. We do the subtraction, which is A equals to A minus M there. So we are going to add the 2's complement of the M, that is 1, 1, 1, 0, 1 to the accumulator. Okay. To the accumulator, which is going to give us 1 and 1, 0. 1 is carry, 1, 1, 1, 1. Okay. Again, I am repeating all the steps. In the pass number 2, we are having the values of accumulator 0. Q is holding 1, 0, 1, 1, 0, and the value of N is 4. First step in this pass is shift left operation. A and Q will be shift lefted. After the shift left operation, the value of A is 0, 0, 0, 0, 1. This one has been shifted over here. 0, 1, 1, 0, and the value of Q with, that is LSB, is left blank there. Then we are going to subtract the value of M from the accumulator. So we are basically doing with the help of the 2's complement method. That's why we are adding the minus M to the accumulator. After doing this subtraction process, what we got? 1, 1, 1, 1, 0 in the accumulator there. So again, as the MSB of the accumulator is 1, that's why MSB is 1. That's why the value of Q is going to be 0. because MSB is 1. Okay, MSB of A equals to 1. So Q naught bit will be equals to 0. Okay, this is the thing which we have done there. Now this is the step number 2, and now we have checked it, and we have the value of Q equals to 0 there. Now, as the answer is negative in the accumulator, that's why we are going to restore back the value of restore back A. Restore back A. Okay, so we are going to add 3 to it. 0, 0, 0, 1, 1. Okay, so 0 plus 1 is 1. 1 plus 1, 0. Carry is 1. 1 plus 1, 0. 1 plus 1, 0. 1 plus 1, 0. And carry will be discarded. Now see back in the value of accumulator, which was this in the pass number 2. Okay, the first value. Why we have restored back? Because after doing the subtraction, we got the value of A to be negative. That's why we are restoring back. So these are the contents of accumulator. The value of Q is 0, 1, 1, 0. And now the value of N will be decremented by all these steps. So how many steps are remaining now? 3 steps are remaining there. Now we will move on to pass number 3. So pass number 3 there. So we are having the registers A, Q, and N there. And the pass number 3, we are the values? 0, 0, 0, 0, 1. And the Q is register holding 0, 1, 1, 0, 0. And the value of N is 3. Okay. So in every pass, the first operation is what? The first operation is left operation. So we are going to shift left the value of register AQ, considering them as a 1 register there. So 0, 0 will be shifted over here. 1, 1, 0, 0, and this will be left blank there. After this, the second step in this pass will be, the second step is to do the subtraction, that is A equals to A minus M, or A equals to A plus minus M we are going to perform. Okay, this is the thing which we are going to implement again. So we are going to add minus M to the accumulator. 1, 1, 1, 0, 1. So this is the addition process. So 1, 1, 1, 1, 1. Okay, since after doing the subtraction, the accumulator, the MSB of the accumulator is 1 there, is 1. That's why the value of Q will be set to 0. Okay, MSB of accumulator is 1. We will set it to 0. And after this, the next step is, because the accumulator is holding a negative value, we are going to restore A. How we are going to restore? For restoring, we have to perform A equals to A plus M there. So now we will add 3 to it. So 1 and 1, 0. Okay, this will become triple 1. Okay, so 1, 1 is carry, 1 and 1, 0. 1 and 1, 0, 1 and 1, 0. 1 will be discarded. So we have restored back the value. So now the contents of Q is 0, 0, 0, 1, 0. A register is 0, 0, 0, 1, 0. Q register is 1, 1, 0, 0, 0. And the value of N will be decremented. This is 2. So now how many steps are remaining? 2 steps are remaining, and we are having this values there. Now let us move to the pass number 4 there of the algorithm. So pass number 4. Okay, pass number 4 is we are having register, we are having Q register, we are having AND register. So A is holding, A in pass number 4 is holding the value 0 0 0 1 0. The Q is holding 1 1 triple 0 there. Okay, 1 1 1 triple 0, and the value of N is 2 there. So in this pass, the first operation will be shift left operation. So we are going to shift left all the values of A and Q register. So this is 0 0 1 0 1 1 triple 0, and this will be left blank. The value of this LSB of the Q will depend upon the next step, which is the subtraction process. Subtraction A equals to A minus M, or A equals to A plus minus M there. We are going to perform. So this is what we are going to add. So we are adding minus 3. So 1 and 1, 0. 1 is carry. 1 and 1, 0. 1 is carry. 1 and 1, 0. 1 is carry. 1 and 1, 0. And the carry will be discarded. So now in this step, after doing the subtraction, the value of A is positive. That is MSB is 0. That's why the LSB of the Q register will become 1. Okay, I'm repeating once again. After doing the subtraction, the accumulator is holding the positive value, as the MSB of A is 0. MSB of the A is 0. That's why algorithm says that whenever the MSB of the accumulator after the subtraction process is 0, the Q naught bit of the Q register, that is LSB, will become 1 there, and the value of N will be decremented by 1. Okay, so this is the we are having in the pass number 4 there. Now last step. So in the last step, what we have to do, we are having these values. So these values are 0 0 1 0. Q is holding 1 0 0 1, and value of N is 1. So we are going to shift left first of all. So doing shift left operation, 0 0 1 0. 1 will be shifted here. Okay, 0 0 and 1. This will be left blank there. Now we are having a subtraction. So we will subtract M from A. So we are performing A equals to A minus M. That means we are adding minus M to the accumulator. 1 1 1 0 1 there. So 1 and 1 0. 1 is carry. 1 1 and 1 0. 1 is carry. 1 and 1 0. 1 is carry. 1 and 1 0 there. Okay, this is the after doing subtraction. Now as the result of accumulator is 0, that's why sorry, here it is 1. Okay, that's why 0 0 0 1 1. Since the MSB of accumulator is 0, that's why we are going to have a value of the Q register to be 1. Okay, Q register to be 1 there, and the value of N will be decremented to 0 there. So now the value of N has become 0. All the steps of the algorithm has been over there. Now what we have to see, we have to see the contents of the Q and accumulator. So as I told you initially in the steps there, that Q is holding the quotient and A is containing the remainder there. So we have done what? We have done the division process. So Q is holding the value 0 0 0 1 0, which is 2, and M is holding sorry, this is the value of A. This is the value of A register. And Q is holding 0, 0, 0, 1, 1, which is 3. Okay, which is 3. As you know that our problem was we are dividing 11 by 3. So 3 threes are 9. We are going to do subtraction and the remainder is 2 there. So the quotient is 3 and remainder is 2 there. So we are having accumulator which is holding the remainder there. Okay, and Q is holding the quotient value. Q is holding the quotient value. So in this way, all the steps are followed. So let us do again one. Initially, we have initialized all the registers. The value of dividend is being held by the Q. The value of divisor is being held by the M. Initial value of the accumulator will be 0 and N will be equals to the number of bits in the dividend there. So in each and every step, what we have done the shift left operation, we have done the subtraction operation, and after the check the value of A. If the value of A is negative, that is MSB of the A is 1, then the LSB of Q register will become 0. And if after the subtraction process the value of A is positive, that is MSB is equals to 0, then this Q0 bit, that is the LSB, will set to 1 there. So if MSB of accumulator is 1, LSB of Q will be 0. If MSB of A is 0, then Q will be 1 there. Now, if after doing the subtraction, the accumulator is holding a negative value, we have to restore back that value. Okay, so for doing the restoring operation, whenever we have got the value of accumulator to be a negative in the third step, that is the subtraction process, we have restore back. So in the pass number 1, we have the negative value. In the pass number 2 also, we were having the negative value there, so we have restore back. In pass number 3 also, we were having the negative value, that's why we restore back. In the pass number 4, we got the positive value. That's why we don't have the step of restoring. And also in the pass number 5, we are having the positive value. That's why we are not having the restoring operation. That's why this algorithm is called restoring algorithm. And the value of remainder and quotient are being holded by the accumulator and the Q register here. So in the last step, we got the value of accumulator to be 2 and Q register to be 3, which are the remainders and the quotient of the division process there. Thank you. And for the books, you can refer these 3 books, Crows, Tannenbaum, and Frozen. Thank you.